Vision. What is a force? In a direction, and it's usually in a form of a
push
or a
pull.
Okay? It's called Newtonian physics. Okay? Or Newtonian forces after Isaac Newton. So if we have a balanced force, it means the acceleration is zero. Okay? So it's balanced. It's either traveling at a constant speed or it's stationary. Does that make sense? So all the forces acting on it are just keeping it where it is or keeping it at a regular speed. Is everyone understanding that? 100%. So if balanced means it's regular, constant speed or it's stationary. Unbalanced means it's starting to increase in speed or decrease. So I'm currently standing in the middle of the classroom. All the forces acting on me are causing me to be balanced, to stay still. As soon as I start walking, I'm increasing my speed. So I'm accelerating to move. So my legs are pushing me forward. Yeah? Push force is acting. So it's is occurring or an acceleration is happening. Okay, capital R. It's a vector, so what do we do with the capital R? Squiggle. Sometimes you'll see it also written as, have you seen this symbol before? Sum of the F. So if the resultant, or the sum of the forces, is zero, what does that tell you? It's a balanced force. Yeah? So if it's balanced, the R equals zero. If we sum all the forces up, and R is a constant or something like that, what type of force is happening? Unbalanced. So what are different forces that could act on something? Gravity, but we don't normally always call it gravity. We call it something starting with W.
Well,
anyone know? Force acting on me now using
Weight.
gravity. Weight. Yeah. The force is the mass times the acceleration. In specialist maths, we use the constant 9.8 for acceleration according to gravity. Nope, that's physics. Always 9.8 unless the question says something else. Okay, so that's weight. What else? What other types of forces? There's lots of different ones.
Inertia.
Well, what about normal force?
Normal force. So the force, I'm standing still, so for me to not travel through the ground right now, there needs to be something pushing back, yes? Otherwise it's not balanced. This is called the normal force.
It's the normal force of gravity.
You got weight, gravity, you got normal force. If I'm going to push something, what could that force be called? We usually call it the applied force. Friction, yep. So often friction is like with a little f like that. So the one pushing down, what did I say it was? The weight force, according using our mass and gravity. What else? There's one other
Resistance from the ground.
obvious one.
Rotation
And
of the earth.
what capital letter do I use?
A.
N. Okay.
Oh, wait, that's
For your shenanigans. Someone who hasn't said anything. What are some of the forces acting?
Errors.
Applied force.
Thermodynamic energy of the combustion.
Drag.
My bad. Drag, capital D. What else? Same as the last one. Weight and normal. So the ground and the train tracks are applying a normal force back. Otherwise the train would travel where? Through the earth. So it's approximately that way. So what is your prediction of approximately the resultant? When we add all of those up, approximately where do you think it's going to go? Definitely go right, because we've got 2 going right, and it definitely will be going, probably going up. So somewhere like that, and they're in Cartesian, I should say.
Don't you add all the i's, then add all the j's together?
Correct. So all the numbers in front of the i's are added together. In front of the i's. 2, take 1, plus 5 is?
6x.
Yep, 6x, or the 6th number in front of I. 3 plus 4, take 2. 5. Okay, so very... All right, question 2. Anyone know what to do?
A squared plus b squared equals c squared.
Very good. We use Pythagoras. So we've got 6 and 5. So the resultant magnitude is the square root of the x squared plus the y squared. 36. It's a 1 magnitude vector. I always goes in the positive x direction. So we've got I there. We've got this vector 6i plus 5j going this way. So yes, trig. Between the vectors, we can use something. Dot product. So r dot I. What's r dot I? So there's 2 forms. We already know these, and we want to find theta. So we've got square root 61, and what's the magnitude of I? Okay? We have the dot product over the magnitudes. Do you remember seeing this? Six times 1 plus 5 times 0. So we got 6 over square root of 61. So we need to bring the cos over the other side, chuck it into our calculator. You guys all okay? Shall we move on?
Yes, please.
Okay, this one's again a little bit tricky. Force 1. If it is changed, if the resultant is changed 1 when we substitute in, instead of writing 2 and 3, we write x and y, because we don't know what it's changed to. The other ones have stayed the same.
Yes, of course.
So negative force 1 equals force 2 plus force 3. Or multiply everything by negative 1. Does everyone understand? I just brought force 1 over to the other side of the equals. And then I'm going to multiply everything by negative 1. Numbers in front of the i's, sums 2. Numbers in front of the j, sums 2. Okay, so if all three forces result to 0, force 1 would have to change to negative 4i and negative 2. You found. Therefore, this is the new F1.